gonna make it on time. By the time I grab my books and I give myself a look, I'm at the corner just in time to see the bus fly by. It's alright, cause I'm safe at the fail. If the teacher pops a test, I know I'm in a mess, and my dog ate all my homework last night.
What's up, YouTubers? It's Pajama Day, so that explains this. But we're going to explain scientific notation, so because that's very important for you to understand. I'm going to do the first two, and then I'm going to have Miss Gardner from the Colts is going to do the bottom two, and then Mr. Hart is going to do some of the more complicated problems that we're going to do, multiplying and dividing. So let's look at the top. So if we look at this one, it has a negative exponent. Okay, which means this is going to be a small number. It's going to get smaller because it is to the negative exponent. So what that means is instead of going to the right and making the number bigger from 3 to 36.5 to 365, we're going to make it smaller. So we're going to take the decimal and we're going to move it 3 spots, 1, 2, 3, and that's where our new decimal is going to be. And we fill in the empty spots with zeros. So our final answer here is going to be 0.00365. So that's for this one. Now, if you're working backwards, so we're given the number and you need to put it into scientific notation, then you just take this decimal and you move it 1, 2, 3, 4, 5, 6. And that's where the new point's going to be. You stop when there is one number that is either 1 through 9 that is in front of that decimal. So it becomes 3.6. And we always use times 10 because that is what we count by. We count by 10. So every time you have ones, goes up to 10, it's a new spot. So that's why it's always times 10. And then you put how many times did you move the decimal? 1, 2, 3, 4, 5, 6. So it's -6, and it's negative because this is a small number. It's smaller than 1. So that's your scientific notation for a smaller than 1, very, very small number. So I'll let Miss Gardner do the next two, and now you know more.
Hey guys, so you just saw a couple examples from Mr. Gossam. We've got 2 more similar examples converting standard numbers to scientific notation and vice versa for you. So right here, this problem, we're given scientific notation. We know that because we've got times 10 and an exponent, and we want to make this into a standard number. So written it out all the way with the zeros. So I look at my exponent up here. I see I have a 4. That tells me how many times I have to move my decimal place. It's a positive number, so I know it's got to be a big number. So if I have my number 5.25 and I want to make it bigger, I'm going to move my decimal towards the right. So I'm just going to count it out. 1 time, 2 times, add a 0, 3 times, add a 0, 4 times. That's where my decimal will end. So my final answer will be 52,500. So the important thing to note here is that the number of zeros at the back does not always equal your exponent. So in this case, we have an exponent of 4, but we only have 2 zeros. And that's partly because our first 2 times of moving our decimal was to get past that 2 and the 5. So just note that we're not just putting 4 zeros at the back, you're actually moving the decimal the number of times the exponent tells you to. Our second problem, we're given a standard number. We want to put this in scientific notation. So this is a really big number. It'd be annoying to write out multiple times. So instead, we're going to use scientific notation. Our decimal starts at the very back of it, and we want to move it so that there's only one non-zero number to the left. So I'm going to put an arrow right here between my 3 and the 8. That's where I want my decimal to move to. So I know my base has to be 3.894. We can cut off all the zeros at the back because they're non-significant digits. But if it's a non-zero number, you have to include it. And now we're just going to count how many times our decimal place moves. So we've got 1, 2, 3, 4, 5, 6, 7. So my answer is going to be times 10 to the 7th power because our decimal moves 7 times. I know it's a positive exponent here, opposed to the one that Gossam did earlier where it was negative, because this is a really big number. If it's a big number, it's a positive exponent. If it's a small number, it's a negative exponent. So that's my final answer in scientific notation. Those are our simple examples. Mr. Hart will now go through multiplying and dividing. Now you know more.
Hey, I'm Mr. Hart, and today we're going to talk about when we are multiplying and dividing numbers in scientific notation. So if we remember our exponent rules that we've talked about last week, we're going to use those same rules when we're dealing with scientific notation. So here we have a multiplication problem. We have 3.4 times 10 to the 5th multiplied by 2.6 times 10 squared. So our regular numbers here, 3.4 times 2.6, since it's a multiplication problem, we're just going to multiply those numbers like we normally would. So we're going to get 8.84 times, we're going to keep 10. Now, since these both have a base of 10, we're going to use our integer rules and just add 5 plus 2. And then I have a final answer of 8.84 times 10 to the 7th power. Because this number has one significant figure, then a decimal point, it's good. I don't need to change anything. This is in scientific notation. Same thing if we have a division problem. When it's a division problem, what we want to do is just divide the two numbers regularly. So 7.8 divided by 2.5 is 3.12, and then we're going to have times 10. Now, if this were an exponent division problem, which technically it is, since they have the same base, we can just subtract our exponent in the numerator from our exponent in the denominator. So we have 3 minus 7. So our final answer is going to be 3.12 times 10 to the negative 4th power. Now, I know when we were dealing with exponents, we said we cannot leave a negative exponent as a final answer, but there is an exception to that rule when we're writing a number in scientific notation. Now, both of these worked out clean because we have one significant figure, then a decimal. This example is going to be a little bit more messy. So, we are going to still multiply 4.9 times 6.4, and we're going to keep with the same rules that we applied before. And we get 31.36 times 10. Since it's a multiplication problem and we have exponents with the same base, we can add our exponents. So we have 9 plus negative 2. So our answer is 31.36 times 10 to the 7th power. Now the problem with this is not in scientific notation because I have two significant figures before the decimal point. So I need to take my decimal point where it is right now, move it after the first significant figure. Since my number was greater than 0 and I'm putting it into scientific notation, that means I'm adding a positive exponent. So since I only moved it one decimal place, I'm going to add 1 to my exponent. So our final answer here is going to be 3.136 times 10 to the 8th power. And now you know more.
I'm saved by the bell.